Right now, beneath the Philippines, the crust is not calm. It is shifting, creaking, and slowly tearing along hidden scars that cross the entire country from north to south. Fresh earthquake clusters, subtle ground movement, and changing stress patterns are all sending the same message. The rocks under our feet are adjusting to something bigger than any one tremor. This has led to a frightening question spreading online. Can massive earthquakes actually split the Philippines? To answer that, three things need to be understood. First, what scientists are really seeing in the latest data. Second, how faults and trenches around the Philippines behave when stress builds. And third, what splitting actually means in real geology, not in movie scenes, but in the slow, grinding reality beneath the archipelago. Over the last several days, seismologists have been tracking a fast-moving sequence of earthquakes across different parts of the country. Some are small main shocks, followed by tight aftershock clusters. Others are shallow quakes, lining up along known fault strands. When these events are plotted on a map, patterns emerge. Lines, streaks, and patches that trace the outlines of deeper structures in the crust. On the technical side, instruments that measure ground movement, like GNSS stations and satellite-based INSA, have started to pick up tiny shifts at the surface. These changes might be only a few millimeters, far too small to see, but they prove that pieces of the Philippine crust are not just shaking. They are actually moving to new positions. For the average person, that sounds terrifying. For scientists, it is expected behavior in one of the most tectonically active countries on Earth. The Philippines sits on the boundary between multiple plates and microplates. To the east, the Philippine Sea Plate dives beneath the islands, along deep ocean trenches. To the west, other plate boundaries and smaller fault systems interact in a complex, three-dimensional puzzle. Running down the middle of the country, from northern Luzon through the Visayas and into Mindanao, lies the Philippine Fault Zone, massive strike-slip fault system, where the crust on either side slowly grinds past itself over thousands of years. When big earthquakes happen along any part of these systems, the crust does not simply shake and forget. It redistributes stress. Imagine a long tightrope with several knots tied along it. If one knot suddenly jerks, the tension around the others changes, even if they do not move right away. In the same way, a strong earthquake on one fault segment can increase or decrease the stress on neighboring segments. This is what seismologists are watching now. Not just individual quakes, but how they fit into the bigger puzzle of stress transfer. So what does splitting the Philippines really mean? In geology, the country is already split in a sense. The Philippine Fault has produced repeated earthquakes over thousands of years, each one offsetting the ground by a meter or more. After many events, a traveler walking across an unpaved road might notice a fence line or rice field shifted sideways, evidence that the land on each side of the fault moved in different directions. Over geologic time, these offsets accumulate. If you could fast forward through thousands of years, the islands would seem to slide and bend along these lines of weakness. But that is not the same as a single apocalyptic tear, ripping the country in half in one day. Massive earthquakes can produce surface ruptures cracks that run for tens or even hundreds of kilometers along the ground. They can offset roads, rivers, irrigation channels, and buildings. They can step across islands, carving new scarps and reshaping landscapes. Yet this splitting remains a step-by-step, event-by-event process. Each large quake adds a few meters here, a few meters there, slowly rearranging the map. Around the Philippines, there are three main types of seismic behavior that matter for the next days, 2 weeks. The first is simple, aftershock decay. After a significant earthquake, the crust around the rupture zone continues to adjust. Smaller quakes pop off as broken rock pieces settle and locked patches release remaining stress. This is normal. The number of aftershocks usually declines over time. and most do not grow into something larger. The second scenario is triggered. Slip on neighboring fault segments. If stress is transferred from one part of a fault to another that is already close to failure, that segment might also rupture in the short or medium term. This can create sequences where one region experiences a strong quake, followed by another along a connected structure, days, weeks, or months later. For the Philippines, this is a realistic concern, along parts of the Philippine Fault and nearby secondary faults. The third is the low probability, high impact event. A major rupture along one of the offshore trenches capable of generating both strong shaking and tsunamis. These events are rare, but they are always part of the long-term hazard picture in a country sitting inside the ring of fire. When agencies talk about rising stress beneath the crust, they are not predicting a specific doomsday event in the next hour. They are warning that the system is currently active, that strain is clearly being redistributed, and that several fault segments are now under close watch for any sign that they might be approaching their own breaking point. This is why official bulletins place such heavy emphasis on time-stamped data. Seismographs, GNSS receivers, and satellites are feeding in real-time readings of ground motion, quake locations, depths, and patterns. If the current sequence behaves like a normal aftershock decay, activity should gradually decrease without any major new rupture. If instead, stress begins to concentrate along a new segment, the spatial pattern of quakes will change. Clusters may grow in a specific direction. Focal mechanisms, the beach ball diagrams, seismologists use may line up in ways that suggest a fault is loading. For communities, the next 48 to 72 hours are less about guessing which specific fault will move, and more about treating this as a live fire drill. A chance to test how ready people really are. In practical terms, that means a few clear steps. If you live near a known fault trace, or inside one of the high hazard zones identified by PHIVOLCS, use this window to secure heavy items in your home. Check exit routes, and make sure every family member knows, drop, cover, and hold on by instinct. Go over where you would shelter during strong shaking, and where you would reunite after it stops. If you are in a coastal area near trenches with tsunami potential, know the fastest path to high ground. Do not wait for phone alerts. If a very strong or long earthquake occurs, you move first. Then look for confirmation from authorities once you are safe. And if you are far from the epicenters, this is still not a time to be complacent. The Philippine Fault and associated systems cut through multiple islands and regions. A sequence that begins in one province today can, over months or years, shift loading to another area entirely. One of the most dangerous myths is the idea that once the big one hits somewhere, the rest of the country is safe for a long time. In reality, each major rupture solves one piece of the stress puzzle while changing many others. Some segments become safer for a while. Others are pushed closer to failure. The phrase, splitting the Philippines, is powerful and scary, which is why it spreads so easily online. But in real tectonics, the story is both slower and more complicated. The islands are already laced with faults, each one gradually moving. The question is not whether the crust is tearing it. The question is how we live with that constant tearing in a way that does not turn every new quake into a mass casualty event. That is where preparedness and clear communication matter more than dramatic headlines. Right now, scientists are doing what they do best: comparing models, updating hazard maps, and watching every cluster of aftershocks to see whether it fades like normal, or shifts in ways that suggest another fault is getting ready to move. They will not be able to tell anyone the exact hour of the next big quake. But they can say, with high confidence, which regions are under more stress, and which types of events are plausible in the short term. What happens next, or the coming days and weeks, will not be decided by fear or rumors, but by physics. Rocks obey stress, not social media. Faults do not care about trending topics. They care about friction, pressure, and time. For everyone watching, There are two ways to respond to a phrase like massive earthquakes can split the Philippines. One is to freeze, doom scroll, and wait for the worst. The other is to treat it as a signal to move, to secure your home, plan your route, check your supplies, and pay attention to official bulletins instead of viral speculation. One path leaves you shocked and unprepared when the ground finally moves. The other gives you a real chance to walk out of the shaking with your family alive. The crust beneath the Philippines will keep loading and releasing for as long as there are plates on this planet that won't stop. What can change, starting right now, is how seriously people take these windows of rising stress. Use this moment while the network is lit up and everyone is paying attention. Because when the sequence eventually calms down, the faults will still be there. The only question is whether the next time they move, you are already ready or just starting to think about what you should have done.